Suppose you've been assigned the job to measure the height of a farmer's silo. Oh, there's your little silo with a weird farmhouse thing on the side. Climbing makes you dizzy, so you decide to do the whole job from ground level. From a point of 47.3 meters away from the silo, you found that you had to look up at an angle of 53 degrees to see the top of the silo. How tall is the silo? Alright, so you're looking for the opposite of this angle, which is, we're going to use x as our variable. So to do that, you can use the tangent function. You use tangent of 53 degrees equals the opposite, which is x, divided by the adjacent, which is 47.3. You can then multiply 47.3 to both sides, as it's meters, in which these will cancel out, and you'll be left with x equals tangent 53 times 47.3 meters. I forgot it here too. And you would come out to be x equals 62.77 meters. And that is the height of the farm silo. Alright, for question 2. Your cat is stuck on a tree. So that's going to be the treetop, and this is going to be your tree trunk, and this is going to be your branch. That's weirdly long. Alright, so your cat's going to be yellow. It's clinging to the branch for dear life. And it is 6.5 feet above the ground. And you only have a ladder. Wait, 6.5 meters. It's 6.5 meters above the ground. And you only have a ladder that is 6.7 meters long. And you want to know what is the angle it has to make with the ground. That's purple. The ground, to be able to touch the tip of the branch to rescue your cat. So to solve this, you know the hypotenuse of this triangle, I guess, and the opposite side of the angle. So you could use the sine function. You get sine of x equals the opposite, which is 6.5 meters, over the hypotenuse, which is 6.7 meters. You plug that into your calculator, and you would get x equals 75.97 degrees. And that is the angle the ladder has to make with the ground to be able to rescue your poor cat. Haleakala is a 10,000 feet high dormant volcano in Maui, Hawaii. Okay, so here's the volcano, and it's dormant, so we can't draw smoke out of it. But it's 10,000 feet high. From the peak to the ground is 10,000 But in order to reach the ocean, the peak is a horizontal distance of only 30,000 feet. Yeah, only. So here's the ocean. And from this point to this point, it's 30,000 feet. At what angle would you have to look up to see the peak if you were standing on the beach? Okay, so the beach is here, just around the ocean, and this is you. And you want to look up to see the peak. So what is this angle? So from this angle, you have the opposite side and the adjacent side. So you can use the tan function. So this is question A. The tangent of x equals 10,000 over 30,000. 10,000 because it's the opposite and 30,000 because it's the adjacent. And plugging that into your calculator, you would get x equals 18.43 degrees. So you would have to look up at an angle of 18.43 degrees to be able to see the peak. Okay, given that, what is the straight line distance from the beach to the peak? Alright, there's a few ways you can solve this. You can use sine, you can use cosine, and you can use the Pythagorean theorem. If you use sine, you would do sine of 18.43 degrees that you got from here equals the opposite side, 10,000 feet, over the hypotenuse, which is unknown and we're going to call y, over y. So you would multiply y to both sides. This will cancel out, and you would get sine 18.43 degrees times y equals 10,000 feet. But you want to single y out on this side. So you would divide both sides by sine of 18.43 degrees. These will cancel out, and you would get, forgot to write sine here, you would end up with y equals 10,000 feet divided by sine of 18.43 degrees, which equals 31,622.78 feet. You could also use cosine, where instead of using the opposite side, you would use the adjacent side. So use cosine of 18.43 equals adjacent 30,000 feet divided by the unknown y. In which case you would do the same thing, multiply y to both sides, then divide both sides by cosine of 18.43, which would leave you y equals 30,000 feet divided by cosine 18.43 degrees, and you would get the same result of 31,622.78 feet. The last method you could do is the Pythagorean theorem, where you would just take 10,000 squared plus 30,000 squared equals y squared, in which case you would solve it out, and y would equal 31,622.78 feet. For question 4, an observer is 5.2 kilometers away from a launch pad and observes a missile ascending. So we're going to make our missile red with yellow flames. And here was our launch pad. And our observer is 5.2 kilometers away. At a particular time, the angle of elevation is 34 degrees. The angle of elevation is 34 degrees. Part A asks, how high is the missile? So it's looking for this length. So to find that, because you know the angles opposite and adjacent, you will use the tangent function. Tangent 34 degrees equals, this is x, opposite x over 5.2 kilometers. And then you would multiply 5.2 kilometers to both sides to get x alone. So x would equal tangent 34 degrees times 5.2 kilometers, which will come out to be 3.507 kilometers. So then part B asks, how far away is the missile from the observer? So now it's looking for this length, which we're going to label as y. There's a few ways you could do this. One way would be the Pythagorean theorem, where you can use x squared times 5.2 kilometers squared equals y squared, and you would solve that out. I'm going to use cosine of this angle. So cosine 34 degrees equals the adjacent 5.2 kilometers over the hypotenuse, which is y. So to get y alone, you want to multiply both sides by y and divide both sides by cosine of 34 degrees. So this will cancel out, and this would cancel out. So you would be left with y equals 5.2 kilometers divided by cosine of 34 degrees, which will get you y equals 6.272 kilometers. So now you know that the missile is 6.272 kilometers away from the missile, and the missile is 3.507 kilometers high. The last question, a team is building a zip line through the skyline of Atlanta. They have 125 feet of steel cable for the zip line, and they have been told the maximum angle of decline can only be 42 degrees. What is the maximum distance the two buildings can be apart? Alright, so there's building A and building B. The zip line is 125 feet of steel cable, and the angle of decline is 42 degrees. So with this, I'm gonna use the sine function. The sine of 42 degrees equals the opposite, since we're looking for the distance of the two buildings apart. The opposite, which is x, over the hypotenuse, which is 125 feet. Then you would do what you did in the last problem, multiply both sides by 125 feet. This will cancel out, and you will get x equals 125 feet times sine of 42 degrees. And that will come out to be x equals 83.64 feet. So you know the maximum distance between the two buildings has to be 83.64 feet.